It's measurement. It's 3D measurement, and I've picked some really interesting questions for you tonight. Let me leave it like that. So I need you to please, 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 please get pumped for tonight. All right. It's time to get pumped. We are swimming in the deep waters tonight. All right. But I know you can do it. I know you guys can handle it. So please, please, please get pumped and ready for the challenge. All right. Let's dive into those waters. Here we go with our first scenario. Mrs. Lingham. Mrs. Lingham instructed her workers to pack coffee mugs into boxes. The dimensions of the coffee mugs and the boxes are given below. There we go. So the box on the left, all the dimensions, and the coffee mug on the right with dimensions. All right. We're packing coffee mugs into the box. Sounds pretty easy. Not too bad. Let's see. First question. Show that the height of the coffee mug is 62.7% of the height of the box. Show or prove. That word show can be translated into prove. All right, so you got to do a calculation to get this answer of 62.7%. Now, if you just write 62.7% when they say you have to get this number, this value, you're not going to get the marks. You've got to show your calculations here. All right. So I want you guys to please try this one, a nice warm up. Show or prove that the height of the coffee mug is 62.7% of the height of the box. Shouldn't be too difficult. Show that the coffee mug height is 62.7% of the height of the box. Now, you guys are going to do the calculation and all write out 62.7% on the screen. That's not going to help me. So I need someone brave enough to come online and show me how they got this calculation or what we should do. Is there anybody out there that can help me with this? Anybody? Anybody? Somebody? There's Mohammed. All right, Mohammed, check your screen there.
Good evening, sir.
Good evening, Mohammed. How are you?
I'm better. I'm good.
Good. How do we do this one?
So I would say 94 millimeters divided by 150 times 100.
Absolutely. 94
And
millimeters.
the answer is going to be 62.66, but we're going to round it off. So it's going to be 62.7.
All right. Excellent. Thank you for that. Perfect. Perfect. Let's quickly do it because we've got to show the calculation. So 94 over 150 times by 100. 62.66666. I'm just going to do a couple of sixes here. You know that there are a whole lot of sixes. And like Mohammed said, we're going to round this off to 62.67%. Well done. Thank you, Mohammed. Excellent. Good job. All right. Nice and easy. Nice warm-up question. All right. So prove, you have to show all your calculations for when they say prove or show. Make sure you write down all the steps that you got. Okay. Not bad. Let's see the next one. Oh my gosh. Eight marks. Now, remember what I said. 8 marks doesn't mean it's hard. Okay? It just means there's a lot of steps involved. That's the challenging part of a question like this, is that you've got to show all the steps. There's a lot involved here. So the chances for making a slight mistake are pretty high. But if you work carefully, step by step, you can get all 8 marks. It says Mrs. Lingham claims that 66 mugs will fit in 10 boxes. Verify, showing all calculations, valid or not. 66 mugs in 10 boxes. All right, now I'm going to go up here and I'll write it on the side. We need to show that 66 mugs can go into 10 boxes. Where do we start? That's the another challenging thing about these long questions is where do we begin? Does anybody out there have an idea? I'm sure someone out there's got an idea of what we do. Anybody?
Somebody,
Somebody?
anybody.
Anybody? Mohammed's on fire tonight. He's keen for the challenge.
100%.
So don't
Mohammed.
we have to work out the area for both, for the box?
Okay, if we do work out the area for the box, then what will we do with it?
Then we'll, doing that, we'll find out the space.
Yes, we do need to get an idea of the space. You're absolutely right. So what I'll do is I like to draw a little diagram here. So let's pretend that this is looking into the box, right? So this rectangle here that I've just drawn is me looking down into the box, first of all. So that's what Mohammed is referring to, is the area in the box. So this is the bottom of the box. Okay, so I'm looking into the box. And Mohammed's saying, work out the area so you can get an idea of space, because you want to fit mugs in here. So Mohammed, what I suggest is draw a little diagram and then picture how many mugs we can fit in there. Now, we know that the length of this box going this way is 310 millimeters. And one mug, I'll draw a little circle here. All right. Its length, or sorry, its radius, that little line there, is 39 millimeters.
So
Okay.
can we just put 78 millimeters, because then that's going to be diameter.
Very good. I'm glad you mentioned that. Like Mohammed suggests, we need to work with diameter instead, because diameter going across, whoops, you don't use that kind of an arrow. Let's do this. Diameter going across the mug like this, that'll tell us from edge to edge of the mug. Then what I can do is I can take this mug and I can actually squash it up in my diagram. Now, you don't have the tools that I have, all right? But I can do this. I can start to actually fit these mugs in, all right? And like Mohammed said, I need to think of diameter. So I'm going to write your diameter equals, I'll just do a quick calculation, 2 radii, 2 times 39, which is equal to 78 millimeters. So one mug there with a line going across it takes up 78 millimeters of space. So how do we work out how many mugs we can fit in lengthways? Mohammed?
We're going to say 310 divided by 78. I mean 78.
Absolutely. Very good.
Then we get 81.
All right, so let's work that out. So I'm going to put into my fraction here, 310 divided by 7. Oopsie.
So sorry, wait,
Okay.
I made a mistake.
That's okay. 3.97.
3.97, yes. I've already
All right.
converted it to meters. Sorry. I mean
That's fine.
centimeters.
That's fine, don't stress. All right, so 310 millimeters divided by 78. So we're taking the whole length of the box and we're cutting it up
So-
into mug spaces. Hold on a sec. Mug spaces. And it says here we can fit 3,79. Now, be careful. That's not 4. Do not round up to 4 mugs. There will not be space for 4 mugs here. Only space for 3 mugs and a bit. So, in actual fact, let me just change this picture a little bit here. All right, I'm just going to change it a little bit. I'm going to make this rectangle smaller. Now, I know what you're thinking, sir. I don't have time to draw all this, and it's fine. I want you to see the idea here. As long as you understand the method, that's the most important thing. So I can fit 3 mugs in like that. I cannot fit a 4th mug in. Mohammed, would you agree?
Yes.
All right. Now I need to work on the width of this box.
It's going to be
Let's work.
220 divided by 78, which equals to 2.82. So we'll just put that as 2 mugs. 820.
All right. So what Mohammed is saying is that we can't fit a lot of mugs in here. All right. We can only fit 2 width ways. So we're going this way now. And I'm just going to draw a little arrow. up like this, we're talking about this way, the width, which is 210. Okay. I'm just going to write it here quickly. Mohammed, just bear with me. I know you're itching to carry on. All right. So we can put 2 that way. And now I'm going to pack in all the rest. All right. So I'm going to put another mug in here like that. And another mug in here like that. Okay, so far we can only fit 6 in here. We can't put 3 widthways because it's 2,8. If it went up, if it was 3 or more, we'll put 3 in, but we can only put 2. All right, so it's 2,8. All right, Mohammed, what now?
Now we go to height.
Very
So
good.
150 divided by 78 equals to 1.923. So we put it as 1 mug.
Very good. Your method is absolutely right. Just be careful now because we need to look at the height of the box, which you said is 150, but now we also need to look at the height of the mug. So we're not going to look at the diameter of the mug, which is 78. Now we're going to look at the height of the mug, which is
94.
94. Yeah, 94. So we're going to say how many mugs can we stack on top of each other? So
One.
that's 1. Yeah. 1.59.
It's just 1 basically.
It's just 1. All right. Now, I'm not going to draw this. It's going to be very difficult. But I want you to picture we've got 6 at the bottom of this box, plus we can stack 1 high, right?
It's
So there's
going to be
6 at the
12
bottom.
mugs.
Yes, 6 at the bottom plus 1 on each of those 6. So there's... Oh, no, hold on, Mohammed. Hold on. We can't stack any. We can only... This height of the box can only fit 1 mug. We can't fit 2 in there. So we can't even stack any.
Oh, yes,
Okay.
that's true.
Yeah, so the height's only 94. So
Okay,
we
sorry.
can't... Yeah, we can't even stack. We
It's
can't even
basically
stack.
only 6.
It's basically only 6. All right. We can do 3 lengthways. We can do 2 across the width. There's only space for 1,59 mugs high. If it was 2 or more, we could stack 2 mugs on top of each other and it would be 6. But we can't. So we're stuck with 1 mug high. All right. We can't put another on top. So all we can do is 6 mugs. All right. Now, the calculations that I've done, I want to just make sure, Mohammed, that was excellent work. Thank you so much. The calculations that we're going to do, I just want to make sure that we set it up properly. Okay, so what I'm going to do is I'll show you here. I'm going to put here this calculation, and I'm going to call it H for height. All right, and we can only put that, so this is only going to be 1 mug. Right, in fact, this sign is not correct. We should say therefore 1 mug. Okay, we're going to do width and we're going to do length. Okay, so I'm going to bring these calculations down. Okay, I'll bring it down like this quickly. Whoopsie. There we go. And this needs to go 310 was the length and 220 was the width. Let me just check. Yes. All right. So those calculations are correct. All right. So I'm going to say therefore 3 mugs. And over here, therefore 2 mugs. All right. So we got the number of mugs lengthways, widthways, and heightways. All right. So now we're going to do a calculation and just say it's 3 mugs times 2 mugs. And we don't have to say times 1, but I'm just going to say it anyway. If it was 2, if we could stack 2 on top of each other, this last value would be 2, but we only have 1 mug high. So therefore, we can only put 6 mugs. All right. Are we done? Let's read the question again. You guys read the question. Are we done?
We're going to have to say, therefore, the statement is correct.
Okay, yes. Well, they're talking about
I think that's
66
Oh,
mugs
sorry.
in
Yes,
10
sorry.
boxes. 10 boxes.
Six,
So
six,
what we,
yes,
this is
okay.
6 mugs in 1 box.
Yeah,
So
so
now we're gonna
therefore the statement is incorrect.
yeah, we're gonna say 6 times 10 equals 60 mugs in 10 boxes.
Yes.
Sorry.
Yes, I just said yes.
Therefore,
Statement is
statement,
incorrect.
yeah, is in. Oh, my handwriting is horrible. Sorry, guys.
No, sir, you should see mine. Mine is in
Yeah.
cursive, like right.
Yeah, no, it's not good. My handwriting is not good at all. Number of boxes, 66 divided by 6 is 11. Or you could do that, yes. Katlecha, you could say that. If it's 6 mugs a box, if they want to fit 66 mugs, they would need 11 boxes. So the statement is incorrect or the statement is not valid. All right. I hope you guys saw that. Now, just to point it out again, all these calculations need to be shown. When you do this, the stacking problems, and you will often get a stacking problem, draw a little diagram to help you, okay? So draw some mugs in there and visualize it yourself, okay? And then do the calculation. So a diagram helps you. You won't get marks for the diagram. It's just a visual thing to help you see how many mugs you can put in here. All right, that will help you out. So these 8 marks, yeah, big question, long question, but not that difficult. Not too bad. Just got to be careful, read the question carefully, and go step by step by step by step. Are we all good with this one? How are you feeling? Are there any questions about this? Mohammed, thanks again for your help. Are we all good? You must speak, never hold your peace. I hope you guys are good with this. Oh, excellent, 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 excellent. All right. Let's see what I have for you. Let's see what else there is. Now, I like this question that's coming up. I like this one. Let's read it. A gutter will be fitted to the length of one side of the garage roof to collect and store rainwater. Guys, this is a real life issue. Rainwater tanks, as shown in diagrams 2 and 3. All right, so you've got diagram 2, the end of the roof where the downspout is. Now, a downspout is that part of the gutter that goes down, or the pipe that goes down from the gutter at the edge of your roof. Okay, that's the downspout. So if you look here on the left-hand side, usually there would be a pipe going down here where the water goes out. All right. So this is the end of the gutter where that pipe should be. All right. And on the right-hand side, this is an overall diagram to show how this is all set up. Rain falls on the roof, goes into the gutter, and then down the downspout and into a rainwater tank. Okay. And they give us this dimension over here, that the length of the house is 6 meters. That's what they give us in the diagram. Then we go down a little bit more and it says the following guideline is given. To ensure that the gutter drains properly, make certain it slopes a ½ inch for every 10 feet towards a downspout. All right, so what that means is for every 10 feet you go across with your gutter, the end must drop ½ inch. All right, so a normal gutter or normal line is straight, but they're saying if it's 10 feet across, it's got to go down a little bit, all right? So it's got to go down ½ inch for every 10 feet across you go. Okay, if you do 20 feet, then you got to go 10 feet, ½ inch down, another 10 feet, ½ inch down. So the end will be 2 ½ inches, or let's just say 2 ½ inches down, all right, a whole inch down. All right, I hope you guys understand that. Okay, so it's at a slope. We have conversion tables here at the bottom. We're probably going to need that. All right. Let's see what the first question is. I hope you guys understand the scenario. Okay. Here we go. Here's the first question. Uh-oh. 6 marks. Should we freak out? No. We're going to look at this one step by step. We can do it. Number 1, calculate how much lower in millimeters the gutter will be at the end in this scenario where the downspout is. In other words, calculate D, which is this little space here, at the end of the gutter for this house. All right. So how much lower will the gutter be at the end for this situation? All right. Well, we know that the whole gutter must be the length of the house which is 6 meters. So we go to, if I'm not going to say anything, I need someone to come tell me. Someone needs to come tell me how do we work out how far down the gutter must be at the end here for this house if we have to consider a 1/2 inch for every 10 feet in this scenario? Somebody? Anybody?
Somebody.
Somebody?
Oh my word, it's crickets.
Crickets. I think I finally caught them. I think I finally got them. The water is too deep. Come on, guys, is the water too deep? Is it too dark for you? It cannot be. It cannot be. There's got to be somebody out there that can tell me how to do this. Oh, it's crickets. Ah, Lee. Lee says, sir, convert the 6 meters to feet first. Yes, because this sentence which says 1/2 inch every 10 feet, we're working in meters in the house. This statement's working in feet. So we got to convert the house's 6 meters into feet first. So I'm going to do it on the side here. All right. I'm going to do it on the side so we can see. So we're going to take 6 meters. And do we have a meter to feet conversion? Look down here. Do we have a meter to feet conversion? No, we don't. So what do we do then? Do we cry into a bucket or a water tank? Do we cry into our gutters? What do we do? We've got to use what we have, right? We've got to use what we have. We've got to use the conversions that we have. So what I'm looking at is I need to go from feet into, from meters into feet. The only conversion between the metric and the imperial that I have is this one here. 1 inch is 25,4 millimeters. That's the only conversion from the metric into the imperial. All right. So I've got to use that one somewhere along the line. Now, what I'm thinking is I need to change this 1 inch equals 25,4 millimeters into a, not an inches millimeters conversion, but a feet meters conversion. I've got to work with that one there and change it into some. I gotta change it into something that I can work with. Galileo. Oh my gosh. Okay, so this is what I'm gonna do. All right. Look now. 1 inch is 25,4 millimeters. So how many millimeters will 12 inches be? Right? Because I know that 12 inches is 1 foot. I want to get to feet. All right, I got to get to feet because I'm working with feet. I'm working with feet over here in my sentence, and I'm working with meters on the other side. What I have is inches and millimeters. So I've got to convert both of them. So first thing I want to do is I'm going to go from inches to feet. Okay. If 1 inch is 25,4 millimeters, then how many millimeters will 12 inches be? What do I want to say? 12 inches? Because I've got a 12 inch to 1 foot conversion here. If I can get 12 inches, I know I've got a foot. All right. So what I'm going to do first of all is I'm going to say if 1 inch is 25,4, then 12 inches, I'll multiply that by 25,4. 12 inches will equal 12 times 25,4. 304,8 millimeters. 304,8 millimeters. You guys must be happy with that. Yes. Now, 12 inches, according to the conversion on the bottom left there, is 1 foot. So I can write here 1 foot equals 304,8 millimeters. But I need meters, don't I? That's fine. I know how to convert millimeters into meters. So all I say is that and I'm going to do a conversion quickly here. Let's do it first. 304 millimeters. You guys know to change millimeters into meters, you divide by 1,000. You know that. This is going to give me 0,3048 meters. Isn't it? Yes. All right, that's not too bad. Okay, just going to move all this up. Create some more space. Okay, so I've got feet and meters now. All right, so all I can say is that 1 foot equals 0,3048 meters. There we go. Now I've got a conversion that I can use. I've got a 6-meter tank and I need to know how many feet that is. All right, so what I want to do is I'm going to say, how many of these 0,3048 pieces can I get out of my 6 meters? All right, so I'm going to say, take my 6 meters and cut it up into 0,3048 sections, because I know each one of those 0,3048 is a foot, isn't it? So I'm going to say 6 divided by 0.3048, and I should have quite a few. There we go. 19.685039. 19.60, sorry, 685039. 19.685039. All right. I hope you're all with me. I hope you're all with me. Step by step. Okay, so I know I've got 19.685039 feet. All right. The question says, calculate how much lower in millimeters the gutter will be at the end where the downspout is. Now, we got to figure out how many inches this is. All right, because they say for every 10 feet, it's half an inch. All right. Well, I've got close to 20, but I need exact figures here. All right. So I want to know how many 10 feet sections do I have in here? So what I can do is I can say, well, how many 10 feet sections do I have? Please note that I'm not rounding off anything. Even though it's close to 20, I'm not rounding it off. All right. So I'm going to say, how many 10 feet sections do I have in 19.68 something something? What's going on here? I need to divide by 10. 1,9685039. 1,96850. I'll leave it like that. All right. Which is, no, I'm not going to round off yet. It's not the end of the question. All right, let me zoom out a little bit, then you can see most of the calculations. There we go. Okay, so I've got exactly about 1.97 of these 10 feet sections in my 6-meter gutter. All right, and they say for every for every one of these 10-meter sections, you must go half an inch. Well, I almost have 2. So it could almost be a whole inch, but it's not going to be exactly a whole inch. It's going to be just short of a whole inch. All right. So now I'm going to say, I don't have 2. I've only got 1,96850 of these things. And each one of them is a half inch. All right. So then how many do I have? It should be close to 1, shouldn't it? So 1.96850 times a half. I'll write the fraction. It should be close to 1. Yes, it is. So 0,98425. 0,98425 inches. All right. 0,98425 inches. I hope you guys are all happy so far. This is how many inches I've got to drop this gutter. Are we done? Are we done? Is that it? What do you guys think? Good. I'm glad you're saying no. Good. Because they don't want it in inches. They want it in millimeters. And I just so happen to have a inches to millimeter conversion. 1 inch is 25,4 millimeters. I don't have 1 inch. I've got close to 1 inch. So I'm just going to say on the left-hand side here. So I've got this many inches, 0,98425 times 25,4. It'll give me close to 25,4, won't it? It's almost 1. 24,9999999. Millimeters, which is roughly 25 millimeters. Sure. Sure. Ladies and gents, that was interesting. How? You have a question?
Hi, sir.
Hey, how are you?
I'm good.
Good, thank you. Yes, what can I do?
Um, I-
Oh, Khaba, you've broken up there. I can't really hear you. Just try again, or otherwise type the message into chat so we can see it there. So I think your internet connection's bad, so just try and type it into chat and we can answer it there. Yeah, Mohammed, I agree with you. This one is a lot more than the 8-mark question. There could be another way to do it. You could use these conversions differently. All right, so this part of it over here, you could do it a little bit differently, but we've picked it out. Okay, let me explain again. Not a problem. Let me zoom in a little bit. One more time. Okay, so we've got a 1/2 inch to a 1/2 inch for every 10 feet. That's what we need to use, and we've got not feet, we've got meters over here. All right, and we want to work in millimeters over here. Okay, so we've got 2 imperial units, inches and feet, that we're going to have to convert eventually into metric ones. We might have to go both either side, or we have to go around, all the way around to get them both. Okay, just picture that in your mind. So what I did at the beginning was I said, the 6 meters needs to go into feet, but I don't have a meter to feet conversion. The only imperial metric conversion I have is this one over here, which is 1 inch is equal to 25,4 millimeters. Now, this is close to what I need. I need meters. All right. They've given me millimeters, and they've given me inches as well. So the inches on the left there needs to go up to feet, first of all, and the millimeters on the right will need to go up to meters. So I'm going to have to change both sides here. So what I'll do is I take this conversion, 1 inch is equal to 25,4, which we have up here, and I said I want to change this to a 12 inch is to a certain number of millimeters conversion, because I know that 12 inches is 1 foot. That's what they tell us here at the top. 12 inches is 1 foot. So I'm going to take my 1 inch up to 12. All right. So that's what I did. I said, if 1 inch is 25, then how many millimeters is 12? So I said 12 times 25,4. That means that 12 inches is equal to 304,8 millimeters. That's more useful to me because now I have a 1 foot into a number of millimeters conversions. All right. So that's the conversion. I'm getting close there now. Now, the millimeters doesn't work for me because I need to work in meters. So I said, well, let's change my millimeters into meters. That's what I did here. I said, divide my millimeters by 1,000. That'll give me meters. So now I've got 0,3048 meters. So the final conversion that I can work with is 1 foot is equal to 0,348 meters. That's workable. Now I go to my picture, which says I've got a 6 meter gutter. So I take my 6 meters and I divide it by 0.3048 sections, because each one of those 0.3048 sections is a foot. And I see that I end up with 19 feet. All right. Now, this question would have been a whole lot easier if they gave you a conversion like this, instead of these two here that they gave you. It raises the complexity of this whole question where they don't give you the metric to imperial conversion that you need. So you have to work with what you got in this case here. And both the inches and the millimeters don't work for us. You could go to the the drawing and the 6 meters there and change the 6 meters to millimeters, all right, that'll bring you down to their conversion in the table. And you could change the feet in the sentence here to inches. That'll work with the conversion they gave you down here. Either way, you have to change both. You have to change both. We can't use the conversion they give us for the diagram and the scenario that they give us. So we had to change these. I changed these conversions to something more workable, which is this conversion over here. This is what I wanted to get. All right. Once I have this, this question now gets a whole lot easier. Okay. So I said my 6 meters works out to be 19, something something feet. And then I want to say to myself, all right, well, every 10 of those feet, I must drop by a certain number of inches. All right. So I said, how many 10s do I have in there? So I divided my 19, blah, 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 divided by 10. I said, oh, I've only got 1,9. Almost got 2 groups of 10 or 20. All right. So I almost have 2 of these sections. Okay. Now we need to go over to this side over here on the left. Sorry, no, we've got to continue. All right. So we almost have 2 of these 10-meter sections. Well, each of these 10-meter sections that I have, you have to drop it by a half. The gutter needs to drop by a half. So I said, well, if I had 2, I would just say 2 times a half. But I don't have 2. I've got 1,9 blah, 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 times a half, which would give me close to a whole inch, which is there. It's almost a whole inch. All right. Then I come to the left-hand side here and say, but I can't work in inches. The question wants millimeters. How many millimeters must I drop it? So now I just take my conversion, which is given over here. That's workable. And I can change my inches into millimeters using that conversion over there. Sure. And you're right. This one should have been for many more marks. All right. So the hard part here is to get a conversion from metric to imperial that you can work with this in this scenario. They gave us meters and feet in the scenario, but they give us millimeters and inches in the conversion table that they gave us. I hope that makes sense. They really do make it difficult for you by not giving you the conversion that you need. All right. Oh, gulp. Let's move on to question number 2. Calculate the capacity in liters of a cylindrical water tank, obviously the rainwater tank, with a diameter of 80 centimeters and a height of 1.2. All right, so I'm going to draw a little diagram here. Okay, I'll draw it on the side so we don't have to keep on referring up to the top. So we've got a water tank here. All right, guys, and please don't laugh at my drawings, hey? You know I'm sensitive about my drawings. All right, there we go. There's a cylinder, and they say it has a diameter of 80 millimeters. That's 80 millimeters. And it has a height of 1,2 meters. All right, a 1,2 meter height. That's what we're talking about here. They want to know, what is this capacity in liters? But they're giving us a volume formula. So we will need to change volume into capacity. Just remember, guys, that volume is meters cubed, centimeters cubed, millimeters cubed, and capacity is liters, milliliters, kiloliters. So we're going to have to change eventually. And they give us a conversion to do that. They say up here in the question that 1 liter is 1,000 centimeters cubed. So I'm going to write that here. I'm going to use that. 1 liter is 1,000 centimeters cubed. My apologies. Thank you for that. That would really cause trouble. It's not millimeters, it's 80 centimeters. Thank you. All right. So that's the information that I have. So who can tell me what I should do? Come on, ladies and gents. It's your time to shine. Your time to shine. I don't want to take all the credit for these questions. You guys need to help me out, Chad. Your time to shine.
Anybody.
Anybody, somebody. Please don't be scared by the previous question. This is a lot easier. It's a lot easier, guys. All right, Mohammed, on fire tonight. Mohammed?
Sir?
Yeah.
So we're gonna basically use the volume formula.
Yes.
So 3,142 times radius is 80. Okay, it's gonna be 40 centimeters cubed times height. What's the height? 1.2 meters. So don't we want to have everything in one?
I'm so glad you said that, Mohammed. You remember my last lesson, which said when you put things into the formula, make sure they are the same units.
Yes.
So this height, I need to change it into centimeters. How do I change meters into centimeters?
1.2 meters times
How
wait,
many
let me just-
centimeters? How many centimeters in a meter?
how many centimeters in a meter? 100.
Yeah. So I need to multiply the 1.2 by 100. All right, let's write this out again. So it's 3,142 for pi times, like Mohammed said, we don't work with diameter. This formula needs radius. Cut the diameter in half. So that's 40.
Squared, so
Oh, thank you, Mohammed. All right. And 1,2 times 100 is 120 centimeters. There we go. So before we even touch the calculator, we've got to get everything into this formula in the correct format. This is why Kia always says, show your units. Because you don't want to put different units into this formula. They're all going to be the same. And why is Muhammad choosing centimeters, by the way? Why didn't he convert the 80 centimeters into meters? Because the conversion that they give us here is a centimeter cubed conversion. All right. If it was a meters cubed to a certain number of liters, then Muhammad would have suggested we change all the units to meters. But because they give us a conversion with centimeters cubed, we want to keep the units as centimeters. All right. So now we're going to put on the calculator 3,142 times, in fact, we don't need the fraction. We just say 40 times 120. Oh, and the 40 must be squared. This is going to give us a big number. Big number. Yo, all right. 603,264. 603,264 centimeters cubed. All right. We've got volume in centimeters cubed, but they want it in liters. That's fine. We've got a conversion that's easy to use. Every 1,000 centimeters cubed is 1 liter. So how many thousands do I have in here? We're going to divide. Cut this up into thousands.
60,000.
Yes. We'll give you 60,3264 liters.
liters.
Round it off to 60,33 liters. Mohammed, thank you very much again. Are you all with me? So where did you get the 100? This 100 here. Thank you for your question. When I put this information into the formula for my height, you see there in the question, the height is this height here. But I don't want to put meters into this formula. I've got to change meters into centimeters, like I said, because I want to work in centimeters, because my conversion that I'm going to use in the end has got centimeters in it. So I want to change everything to centimeters. So 1,2 meters, there's 100 centimeters in 1 meter. So if I've got 1,2 meters, I've got to times it by 100, which means I get 120 centimeters. Okay. All right, Emanati, I hope that makes sense. 603,264. Are we all good, ladies and gentlemen? Sure, we are diving into deep, deep waters. Deep, deep, deep waters. I'm scared to even show you the next one. Do you want to try another one? Should we try one more? Arthur's keen. Arthur, is that yes for you're okay, or yes you want to try another one? The rest of y'all are quiet. It's crickets out there. Where's people like Chiamo? Huh? Should we ask Chiamo? Chiamo, do you want to try another one? All of them. Yo, I love it. Emmanuel's like, please make it stop. All right. Let's have a look at one more. We've got not much time. We might only need, oh, sorry, there's a question. Look, Lolo, just check your screen there.
Good afternoon, sir.
Good evening. How are you?
I'm good, thanks. How are you, sir?
Good, thanks. What can I help you with?
Oh, sir, this question. Oh,
This one's not as bad as the one before. I think this was a little bit easier than the one we just did before with the gutter. That was a challenging question.
yeah, sir, all those questions I had. Oh,
These ones are hard to not. All right. You know what? We'll look at this, guys. What I'm going to do is we're going to look at the next one. We're not going to do it because we don't have time. But I just want to just chat about this for a second. All right. I don't want you to be discouraged by this because you can't measure the whole subject by these questions tonight. If you've been here a while, you'll have gauged the level of questions we've done up until now. And it hasn't been that bad. Yes, they do put these heavy 5, 6, 7, 8 mark questions into the measurement section. This is why a lot of people, I remember I think it was Ben and a couple of other matrics were saying it's the measurement section that they were worried about the most because they dump these really heavy questions in here and you've got to think really carefully, all right, especially when you're converting. The biggest, the complexity in these questions is conversions between units, all right? So that adds difficulty when they don't give you the conversion that you need to use. You got to go from imperial to metric and maybe even back again. So converting raises the complexity of the question. All right. So keeping an eye on the units that you need to work with is very, 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 very important. All right. So this is why Kia always says, please make sure you show your units. All right. Gabo, I'm going to come to you now. So keeping track of the units is very, very important. I've written units all over the place here tonight to see what units I'm working in, what units I need. All right. And the measurement questions always have a formula that they give you. When you put anything into a formula, please make sure that all the units are the same. That's half the work done. Okay, that's half the work done. And I know you guys are thinking, but where do I start with a question like this? Start with what you know and start just putting some steps down, some methodology down on the paper, and you will build to it. Having said that, for an 8-mark question, if you get to the 8-mark question and you read through it, and you'll get used to it, you'll read through the question and you'll be like, I don't have a cooking clue where to even start with this 8-mark question. Then what you need to do is move on. Don't sit there and wrestle with the 8-mark question for 15 minutes or 20 minutes and say, I'm not moving on until I try to tackle this. Some people are like that. They like the challenge. Other people will sit there and get bogged down in an 8-mark question. Don't do that. If you see there's an 8-mark question, you think, oh, this is the big one. Read through it once or twice. You might immediately get an idea of what you need to do and then start. And then if you get bogged down halfway through, don't try and finish it. Leave space, move on, put a star next to it. Go finish everything else and then come back and wrestle with this. Don't wrestle with a question like this in the middle of the exam, get beaten up, and then try and race through the rest. Okay? Wrestle with the big guy at the end if you can. But you might read through it and you might say, actually it's not so bad. And then try it. But just keep an eye out on your time. Nokolo will come back to you now. So I'm gonna go to Gabo. Gabo, you have a question? Just check your screen there.
So I don't understand how you got the ending answer because I got 603,264.
Okay, let me just check the calculation. I didn't actually do it on the calculator. I tried to do it out of my head, which is not very smart because I bought this calculator and it needs to work for me. So it's got to do it to work for me. So let's do 603,264 divided by 1,000. You're right. Oh, sorry, I did it out of my head, which is silly. The calculator does all the work for me. I bought this thing; it must do the job. Yes, so it's the decimal's in the wrong place there. Thanks for mentioning that. Awesome. Okolo, let's go back to you.
So I was asking that for like in an exam now, because if the question is out of 8 marks or even 5 marks, can we at least get a shorter formula to do it? Because now this is long, so
It depends on how they set the question. It really depends on the individual question and the context that they have. A straightforward question will give you all your units in the right format plus a very short conversion, and you just plug it into the formula and you go. So for example, a very basic question will give you a nice radius, will give you a height, all in the same units, and say, what is the volume of the cylinder? That'll be for like 3 marks maybe. Now, then what they do is say, all right, well, let's make it more difficult. That's my trick. So let's not give them a radius. Let's give them a diameter. So you got to change diameter into radius. Oh, I'll tell you what, let's make it even more complex. Let's not give them all centimeters like they should have. Let's give them 1 in meters and 1 in centimeters. That raises the complexity. Then you're going to change your meters to centimeters first before you go into the formula. And let's not ask them for the volume in centimeters cubed. Let's ask them for capacity in liters. We'll have to give them a conversion, but let's ask them for that. And that raises the level of the question as well. At the core of the question is you've got to work out the volume of this thing. And before you put anything into this formula, the volume formula, you've got to make sure all your units are right and make sure your diameter is a radius. And then everything's ready to go into the formula. And when you get your answer at the end, does the question want centimeters cubed? No, it wants liters. Oh, well, they have to give you a conversion for that. And you're going to have to use your conversion for that. All right. Now, the question we did previously with the this one here, this is even more challenging. There's 2 or 3 extra steps that you got to do, before you even get to saying take the gutter and work out how many millimeters down we go. There's like 4 different conversions you got to do before you finally get to your answer. It's just raising the level of complexity of a question by not giving you the units that you really need. You've got to go a roundabout way to get your answer. But they can't ask you anything more complicated than determine the volume, determine the heights, determine the capacity. They can't ask you trig. They can only ask you these things that you know. It's just how they present the question to you. Do they present it all directly? Can you throw it straight into the formula? Or do they make you do an extra step, or 2 extra steps, or 3 extra steps, or 4 extra steps? Every time they add a step, they add marks onto the answer. So what should be a 3 now becomes a 4 or a 5 or a 6 or a 7 or an 8 mark question because of all the extra steps. Okay, you've just got to approach it very, very, very carefully, step by step. Start with something and then move on and then move on and then move on. But like I said, please don't get bogged down in these type of questions. It depends on the units you have, the units you're trying to get to, and the conversion that they give. All right. It doesn't matter what conversion they give you, you can work with it either way. You're either timesing or dividing. All right. I'll try and mention that in our next lesson on Tuesday. I'll put some examples there, but you can work with any conversion that they give you. It's either times or divide using that conversion. I'll try, just remind me of that next week, Tuesday. I'll try and bring up some examples to help you with that.